Hello everyone, welcome to this demo video where I'll be walking you through an application I developed that lets you easily configure and train a convolutional neural network on the MNIST dataset. This app allows you to build and compare two different CNN models in real time. As you can see, the web page offers a simple and a intuitive interface for setting up our CNN model. Here, we can customize various parameters including a batch size, optimizers, number of epochs, and the learning rate, and also monitor how these parameters impacts the training process of these two models. Now, let us take a look at how to configure the CNN architecture. So here, the first text box takes the model 1 kernel sizes. So here I have constructed in the backend, I have constructed a three-layer CNN architecture. So I will be providing a sample the kernel sizes 16, 32, and 64. For the model 2, I will simply choose 8, 8, 3 layers of 8 cross 8 kernel. Sorry, it's not 8 channel kernels. And I choose the optimizer as Adam. The batch size is 16 because I have a small GPU, so I'll go with a smaller batch size. And the number of epochs as 5 for the demo so that the demo gets completed faster. And the learning rate of 0.001. So I click on my train and compare models button. So as soon as I click, the model training has been started. So let's give it some time so that the first epoch starts running now, and I will be getting the model summary of those two models once the models are created. And also I'll get a real-time update of which epoch is running, what is accuracy of that particular epoch, and what is the loss of that epoch. So I'll be getting it for the two different models in a real-time manner. So let's wait for the training to the first epoch to be completed so that we get an update of the model. So now you see the model 1 has been created. So this is the architecture of model 1. So we have 16 into 1, that is a grayscale image of 3 cross 3 kernel size. Then again 32 channels. The second layer consists of 32 channels. Again, the output is 16 channels, and then we have 3 cross 3 kernel. So similarly, the third layer is of 64 channels output, 32 is the input channel, and 3 cross 3. So now in the same way, we have also got the model summary for the second model. You see the convolution layer starts with 8 cross 8, 8 cross 8, then again 3 cross 3 kernels and 8 channels. And then we convert the yeah, 64 channels into linear dimension of 256 cross 3136, and then finally we will be predicting the numbers. So 1 to 0 to 9 we will be predicting, so that is why we have the output neurons as 10, and then we pass in the 256 from the last layer. So the same thing holds good for the model 2, and the number of parameters in the model 1 is around 8 million parameters, and you see for the model 2 it is less, 10th, so we have around 1 million parameters. So in the first epoch, we see that the accuracy for the first model is around 96.34% and the loss is around 0.114. And we also got accuracy and the loss plot. So the blue line indicates the model 1 and the orange line indicates the model 2. So the model 2 is right now getting executed, and also we have the test samples. Um, you see randomly what happens as soon as one epoch gets completed. So we send in a random images from our test data set and see what is predicted versus actual. So let's wait for the second epoch and see how the data changes here. So you see, we are in the second epoch right now for the model 1, and we have got the accuracy details. So the accuracy details in this particular thing has to be yet to be updated. So we'll just give it a uh, give some time for it. So as one epoch gets completed, even the test samples will change. I think for model 1 it is being changed. Let's wait for the model 2 again. Yeah, you see, for model 1 and model 2, again the random test evaluation has been changed, and we can see that 7 is predicted as 7, 5 is predicted as 5, and we are in the third epoch right now. So let's wait for the all the 5 epochs to be completed for both the models. So the model 1 in the first, the epoch, it is giving around 94.86, and I think the second epoch is getting trained. Uh, So yeah, so all the epochs has been completed right now, and we have the accuracy versus loss plot, and also we have the sample, the change, the test samples got changed. So in this way, this particular application lets you experiment with different model, kernel sizes, and also the model parameters, like you can try out with a different batch size, you can increase the number of epochs, you can change the learning rate, and lets you experiment and compare two different models, and you can pick which model is the best one for suiting to your requirement. So that's about this particular application. In case you like this video, please um, give a like, and also let me know your feedbacks in the comment section. Thank you.